Thank you so much for the introduction. One of the things I actually love about visiting the Qualcomm office is I think that there's some sort of shared culture and DNA in Qualcomm and MLCommons. I think one of the things that's very nice about MLCommons is we're not just an industrial organization, we're not just an academic organization, but we kind of bridge the two together. So there's sort of a very nice intellectual focus there. And one of the things I'm reminded of as I walked into the lobby of this building is there's plaque upon plaque upon plaque of patents, right? And Qualcomm as an organization has a tremendous respect and emphasis on intellectual property, right? Which is very much at the nexus of that sort of research and development. So I think there's a lot of consonance there. As Etienne said, I'm one of the co-founders of MLCommons. There's especially in the early days, was an effort of many people, other folks in the room. I think Peter Mattson, of course, Tom St. John, many of us were involved early on. So, and thank you very much for taking the time to join us. So one of the things that, for those of us who work in AI, I was talking with Anka, and she was saying she was so busy, flying with her fingers in many different pies, from academia to the EU to research. And I think for many of us in AI, it's felt like a very exhausting marathon. And that's both wonderful because that is a measure of the speed of development, but it's also challenging to keep up with, right? And that is part of the challenge, right? Which is, we see so many different models coming out so often that I remember in the early part of this year, people were starting to ask me, when is MLPerf going to get Model X? And then the next week, everyone had forgotten about Model X, and it was now Model Y, right? And this is incredible because with each model release, we see new capabilities, we see new things that might be on the horizon of possibility, and it is really happening in real time. But it makes keeping up with this incredibly challenging, right? When the state of the art changes on a week-by-week basis, right? And so it means you need your tooling, your infrastructure, and everything to be a lot more robust. If you just want to clock your top, I was just diving in Mexico, and if all you want to do is record the deepest you got, right, for safety, that's fine. But if you want to know where you were at every point in time, you need very different measurement and tooling infrastructure, right? And so velocity and frequency of measurement impose certain demands. So one of the things that I did in looking at this is I pulled together a chart with the assistance of Dave Graham, our head of marketing, who got this into a fantastic form. So on the x-axis here, we have time, right? And this is about the last 2 years. And on the y-axis, each lane is a major AI research house, and each point is a release of a model or a model capability. And I pulled this into an Excel sheet and I looked at it and I said, okay, this is why we're all stressed out, because the rate of change is just incredible, right? You look at, I think they called it the week of shipmas for OpenAI. You can see around December of 2024, you have like 4 or 5 models being released, right? And so the pace here is truly astounding, right? The other thing that we see going on is also widespread adoption, right? And so this is, I just took these numbers. These are, I think, monthly active users from OpenAI. And so what we see is not only are models and capabilities being added more quickly than ever before, and frankly, more quickly than anything I can really remember in my history in the tech world, but we're also seeing the use expand dramatically, right? And so, pre-chat GPT, my parents certainly knew about AI, but mostly because they would make the mistake of asking me what I did for work, right? Post-chat GPT, everyone's parents knows about AI. And all of a sudden, much more subtle things like GPUs, accelerators, AI infrastructure, power for AI infrastructure is now sort of something that everyone, well, not everyone, but many people think about. And so we have this both acceleration in the cadence and the impact of AI is becoming much broader, right? And so that presents a very significant challenge and also opportunity, right? And so when you think about this, I think a good metaphor and one that Peter often likes to use is flight. In the early days of flight, things would advance by leaps and bounds. There were all sorts of people working on different styles of flight, right? In the early days, we had folks who were rigging up things that kind of looked like bicycles that would then flap their wings and kind of emulating conceptually a bird, right? And that sort of biomimicry we even see in AI, right? When people talk about convolutional neural networks, you often say that's inspired by how the visual cortex worked. And again, loose inspiration, but you see those sort of same patterns. And so with this rapid advance in capability, right, there's also tremendous opportunities and need to bring down risk and reliability, right? One of the things that I think is very beautiful about airplanes is that by and large, except for the 737 MAX and the recently grounded Airbus, right, you generally don't worry about what plane you're on, right? You're gonna get from point A to point B, it's safe. And the only time I really care about the plane that I'm on is when I'm looking up the seat map to figure out where I'm gonna sit, right? That's absolutely critical. But is it a Boeing 787, 777? Largely a very superficial thing. But in the early days of aircraft, absolutely, the safety, the capabilities were tremendously disparate. And that's kind of the era that we're in for AI. And that makes the work on understanding risk, reliability, performance, all of those things that we want to measure ever so critical, right? Because it's by setting up this measurement in the early days that we can bend the curve in the long term and ensure that AI is going to evolve into the right place, right? Where it is doing as we want. And even today, I was, for Thanksgiving, I was in Puerto Vallarta, and I tried to look up, I tried to get an unnamed large language model to cough up 5 recommendations of places with birria. And it failed, right? It probably could only find 2 or 3 that were open, and then just said, hey, I can't do that, right? And so we are pushing the boundaries of what is possible with these tools, even with fairly ordinary asks, right? And getting to be able to measure this, getting to characterize it will help us drive improvement significantly faster. Now, many of you in the audience are academic in nature, and as I hinted at rather explicitly, MLCommons is an organization that takes great pride in not just being an industrial organization, but having a very academic bent to it, right? Many of the people who came together to help build MLPerf in the early days, which was our first project, were from academia. And there's different things that academia and industry bring to the table. In industry, we get to move fast, right? Particularly in the software landscape, we can run really large experiments. Many of the things that are done with some of these extremely large models, you can only really do in industry. And even within MLPerf, some of the challenges that we have when we build large-scale training benchmarks, those can only be done with the assistance of our industrial partners. If you want to characterize the speed and performance of a large language model over, say, 10 or 20 or 50,000 accelerators, it's very challenging to do that in an academic setting. However, with the right industrial partners, not a problem. You can move very fast. However, the industry is prone to fragmentation and marketing that runs wild, right? And the early days of MLPerf, I like to say that we came upon a world, and it was as if you were buying a car, and one vendor would say, my car can go 200 miles an hour. The next person would say, my car can go from 0 to 60 in a quarter of a second. And the third person would say, my car has airbags. So, you know, that's great. It's all useful information, but it's entirely non-comparable and doesn't really help you figure out which car you should buy. I live in San Francisco, so I'd take the airbags, you know, or maybe the quick braking one. But, and so, you know, MLPerf itself and many of our benchmarks are designed around how do we get this comparability? How do we help people understand what it means to be good and develop this common language and understanding? Right? But our friends in academia bring many, many valuable attributes here, right? There's this notion of peer review. That's an underpinning of all of our benchmarks at MLCommons, right? Getting to think carefully about things, getting to pick the right thing, and that sort of deeply analytical process is much more of an academic tradition than you'll find in most industrial settings where the key thing is, okay, guys, we've got a ship, right? And so bringing those two things together, I think, is actually really unique, something we're very good at, and it's something that's incredibly important in the notion and in the space of standards, right? A standard is not just getting a million folks in the room arguing, but it's, you know, you have to think deeply about these things. You want things to be verified, right? Why do we, you know, Etienne was talking about Wi-Fi, right? Or if you look at wireless, right? Those are all great standards, but part of the value of a standard is the verification, the certification, making sure that things abide by the standards, because that's what gives them the power that brings so many benefits to people, right? And that's true not just for speed, for energy efficiency, but increasingly as we're working with air around safety and reliability. So when I talk about MLPerf, one of the things I like to say is that it is a full system problem, a full system approach. And the goal of MLPerf, for those who aren't familiar, is how do we measure the speed and energy efficiency of AI? And one of the things that's beautiful about AI today is that since it is our most pressing computational problem, we throw every trick in the book at this problem. Everything from how do we develop more advanced transistors, whether it's a gate-all-around architecture, whether it's new metallization schemes to speed up interconnects, to more advanced packaging, to better software in our compilers, to better algorithms, to better numerical representations, the move from 32-bit floating point down to people using 4-bit floating point today saves tremendous memory, saves tremendous power, and accelerates the speed of training and running inference. Right, we see significant advances in networking. And you know, this is an example of where initially in training, networking was a very significant bottleneck. But when we started doing MLPerf inference, networking was sort of an afterthought. But now today, we see networking and larger scale systems is a tool that people are using to tackle the demand for inference. So, you know, I think one of the lessons here is that for any given tool in your toolbox, sooner or later, if you have a pressing problem, you will find yourself taking that tool out and needing to use it. And that's a testament to the brilliance of our engineers, the brilliance of our researchers, which is they're inevitably going to look at different options to squeeze out more performance and energy efficiency, and in turn give more capability, right? And of course, as we've been talking about, more capability also means, you know, how do we use that capability safely and in alignment with sort of what we want? How do we get it so that when I ask for 5 birria restaurants in Puerto Vallarta, I actually get 5 birria restaurants instead of, I'm sorry, I can't help you with that. And then I have to go ask for 3. Admittedly, I was probably fine modifying that query. So MLCommons has a number of projects under its portfolio. we, as I've alluded to, bring together industry and academia. We have over 125 members on 6 out of 7 continents. If you have any academic researchers at McMurdo Station, please let me know. 7 out of 7 always sounds better than 6 out of 7. We are all focused on collective engineering, on building standards, and on building things that embody those standards to help the industry, to help academia and the broader community move forwards. MLPerf, which is our oldest set of benchmarks, we have over 90,000 performance results to date across 6 benchmark suites. We also have, and some of them are broader and more cross-cutting, like MLPerf training. How do you measure the speed and energy efficiency of training? Some of them over time are focused on specific verticals. So James Goel, who's in the audience, helped lead the creation of MLPerf Automotive, which is the automotive industry came to us and said, hey, we love the benchmarks you built for data centers, but as cars are getting more intelligent, we need to measure the speed and energy efficiency of what goes on there, right? And as AI touches more and more places, we're going to see that need in specific verticals only grow. And all of this is backed by data, right? One of the things that we've done from our very earliest days was to build large-scale open data sets and tooling around data sets. So for example, for all of our automotive benchmarks, there are all specific automotive data sets to ensure that they are relevant, right? As we think about assessing for risk and reliability, the tools we use for that, it's all data, right? It's how do we get a set of queries and look at the responses that we're getting, and are those within the bounds of what we expect, what we desire? That is all using data to characterize these systems. We also have tooling like the Croissant metadata format, which is oriented around how do you take data, just raw data, and make it legible and digestible to AI, right? The world is awash in data. But many of our models are incredibly computationally demanding, and so we're only using just a fragment of that data in the training or post-training process. And some of that is that the mechanism for taking data and making it accessible to AI was not so clear. Things like Croissant can help with this, which in turn will allow us to do more and more things with AI that were not possible previously. Yeah, so these are just a few of our marquee benchmarks and efforts here. I've talked at length about MLPerf, about some of our work in data sets and croissants. Croissant, not to be confused with the lovely croissants that Qualcomm provided this morning. And then we have work on AI Luminate, our risk and reliability benchmark, which I think we had a release late last year, correct? Yeah. And then our work in federated evaluation for medical AI. So many different areas that we're looking on. And if you're a student in the audience, hopefully some of these will be exciting to you and they might spur you to think about where you can take your own research or what kinds of things you might wish to do as you graduate and either enter industry or go on to academia. So, as I mentioned, we've built a number of tools for measurement that are all industry standard or becoming industry standard, or in fact, worldwide, formally recognized standards, right? As I said, MLPerf has been around for nearly 7 years at this point. AI Luminate, roughly a year old, but the effort dates back about 2. And Croissant, roughly about 1 to 2 years old. All of these things help to reduce friction and improve the adoption of AI and bring those capabilities to more people and places. So that's my spiel. And please feel free to ask any questions about any of the things we have going on. I'm happy to answer them. Or we can, who do we have up in queue? Do we have any questions?